Hello everyone. I'm here today to present our paper, Construction Work Zone Safety, Identifying Critical Crash Factors and Patterns in Florida. Our goal was to understand when and where work zone crashes differ from non-work zone crashes, what conditions are most commonly associated with them, and which factors appear to be most related to crash severity. At a high level, this study asked two questions. First, how do work zone crashes differ from non-work zone crashes across time, location, environment, and driver behavior? Second, which factors are most strongly associated with severity outcomes? Rather than looking at one dimension in isolation, we used a comparative and statewide approach so the findings could be interpreted operationally by transportation agencies and construction stakeholders. This study matters because work zones change lane alignment, traffic flow, visibility, and driver decision demands. Nationally, work zone fatalities remain substantial, with 898 deaths reported in 2023. Florida provides an important context because it combines heavy roadway construction, dense metropolitan traffic, and weather variability. Existing studies often examine temporal, spatial, environmental, or behavioral factors separately. Fewer studies compare work zone and non-work zone crashes statewide, and even fewer combine descriptive statistics, significance tests, GIS hotspot mapping, and machine learning severity modeling in one workflow. Our contribution is that integrated, 8-year Florida analysis. We use Florida Department of Transportation crash records from 2016 through 2023. Work zone crashes were identified using the FDOT work zone flag. We cleaned and encoded the data, derived temporal variables such as crash hour and weekday, and then applied 3 layers of analysis. First, descriptive statistics and significance tests, including chi-square tests and t-tests. Second, geospatial hotspot mapping using kernel density estimation. Third, severity modeling using XGBoost and random forest, with feature importance analysis to interpret which factors mattered most. The temporal figures show that work zone crashes follow different timing patterns than non-work zone crashes. Both categories declined in 2020 during the COVID period, but non-work zone crashes rebounded more sharply afterward. Work zone crashes show a clearer summer peak, especially in July. They are also concentrated on weekdays and during daytime hours, with the strongest concentration roughly between 7 a.m. and 5 p.m. That pattern is consistent with active construction schedules, while non-work zone crashes extend more into evening travel periods. For practice, that means work zone safety interventions should be timed around actual exposure windows, not applied uniformly across the day or the year. Spatially, crash concentrations are strongest in major metropolitan counties such as Miami-Dade, Broward, Palm Beach, Hillsborough, and Orange. Work zone crashes closely follow construction-dense corridors like I-95, I-75, and I-4. Environmentally, work zone crashes show a higher proportion of rainy condition and wet surface incidents than non-work zone crashes. Daylight dominates overall, but nighttime incidents remain meaningful. Taken together, these results suggest that both place and operating conditions matter, especially in urban corridors and during adverse weather or lower visibility situations. This also suggests that safety planning needs to be both location-specific and condition-specific. This slide summarizes severity model performance using XGBoost. The machine learning results answer a different question than the descriptive analysis. They tell us which variables are most strongly associated with severity once many factors are considered together. The most influential features were the number of vehicles involved, alcohol impairment, and speed-related variables. That matters because it points decision-makers toward conflict reduction, speed control, and impaired driving prevention as levers for risk mitigation. The main takeaway is that the models distinguish non-severe outcomes reasonably well, but rare events such as serious injury and fatality remain much harder to predict, which is typical in imbalanced crash datasets. Here we move from performance to interpretation. The top predictors differ by crash context. For work zone crashes, severity is more influenced by pedestrian and pedal cycle involvement, number of vehicles involved, alcohol-related crashes, and rollover or overturn events. For non-work zone crashes, parked motor vehicle collisions, pedestrian and pedal cycle involvement, number of vehicles involved, and intersection-related factors are more prominent. So the severity mechanisms are not identical across environments. In work zones, vulnerable road users and alcohol stand out more strongly, while outside work zones, roadway context and parked vehicle interactions play a larger role. The behavioral results make the work zone environment feel more concrete. Compared with non-work zone crashes involve more careless driving, more right-of-way violations, and more following too closely. Those are exactly the kinds of behaviors we would expect to matter when drivers are dealing with narrowed lanes, temporary control, and unfamiliar geometry. Operationally, that suggests temporary traffic patterns place greater demands on yielding, spacing, and driver attention. These findings translate into practical implications. In terms of timing, agencies should prioritize enforcement and monitoring during daytime operations, weekdays, and summer construction peaks. In terms of location, major urban corridors deserve priority, but rural higher-speed segments should not be overlooked. In terms of conditions, agencies can consider whether responsive traffic control, friction treatments, drainage attention, and improved nighttime visibility. And in terms of severity reduction, strategies should focus on reducing multi-vehicle conflicts, managing speeds, and addressing alcohol-related exposure. To close, the paper shows that work zone crash patterns are systematically different from non-work zone crashes across several dimensions. The practical message is that agencies should use these patterns to target safety interventions by time, place, condition, and severity-related risk factors. I'd be happy to discuss the modeling choices, the Florida context, or how this framework could be extended in future work.